Okay, tell me what's up.
Sir, can I present my
Yeah,
screen because
yes.
doubt it would
Sure,
be
sure. One
better.
minute. Yeah,
So,
I'll give you permission.
yes, sir.
Yeah, please go ahead.
Um, just a second, sir.
So, generation of random numbers. Okay, sure. We will go through that. Random numbers. One topic we take.
so, sir, can you see my screen?
Yeah.
So I have done this whole assignment. Just I have a question. I can't do this one. Question number 4. Uh, this. Can you see it properly? I'm first time using this feature. So
Okay. Problem number 4.
yes, sir.
Write a program that reads an integer entered by the user, displays it in octal. Basic.
Um, yes, sir. So can you see my code, sir?
First, before looking at the code, what is your logic?
The way I see it is that if we have a number like say 343, for example, so if I had to divide it in decimal system, I'll divide it first with the highest power of 10, which is 10 to the power 2. So if the number is 343, I'll divide it with 100. So I'll get 3.43. So I would floor it so that I would get the first digit, and the modulo of it will carry forward on to the next one. So 343 will get converted into 300 plus 43. Then again, I will um, someone.
Okay.
Uh, I'll should I show my code or
Yeah. So just thinking. Um, when you take 342 in order to, so you know how many twos are present in it, and no 343. How many tens are, how many ones, how many tens, how many hundreds are present in it. Uh,
yes, so,
so
sir, can you see my screen? So I'll explain it right here, so it would be easy if I do it with. Can
okay,
you
tell to me.
can you see my code, sir?
I'm not able to see your code actually. I'm able to see the, it's a program.
Um,
I'm not able to see your code, so
Sir, could you tell what you can see on my screen?
I'm able to see the book, the your browser.
Okay, sir. Sir, is it visible now?
Yeah.
Yes, sir. So here, this is my code. So what I'm doing here is that at first I know that 32,767. So 32,768 is 8 to the power of 5. So I know that all the numbers between 0 to this one are less than 8 to the power of 5. So what I'm doing here is, at first I'm taking this number and I'm dividing it by 8 to the power of 4, and then I'm flooring it. So So similarly, if I had 343 example as an example, and I had to divide it in base 2, so what I would do is at first I will divide it with the highest power of 2, which is less than that number. So in this case it would be 256, right sir? um, Forgive my bad drawings. If I were to convert this into binary, at first I will divide this by 256. So that would give me a
Yeah, I
1.
think this could be a bad logic. I don't think it may quite work. Yeah, Naman, this is only class related topics. So maybe a better way to think about it is, yeah, I'm not sure about your approach. It could be an incorrect approach to reach out to the problem. Uh,
So,
so
sir,
can you
if
unshare?
you,
I will show you
yeah,
the kind of logic which could be better
yes, sir,
for you.
yes, sir. So how do I unshare? Yes, sir. Um,
Let me see if I get this right. So when you represent a number, some number is there. Uh, let's say if there is some number, so 843, this is equal to 8 times 10 square plus 4 times 10 power 1 plus 3 times 10 power 0. So in general, if you take a k plus 1 digit number, dk to d0, its value is equal to sigma I is equal to 0 to k uh, di times 10 power I. That is its value. Are you with me here?
yes, sir.
So if it is a base b number, so since these are all, this is a decimal notation, so each of these di's, if you see, each of these di's, they lie between 0 to 9, since this is decimal.
Yes, sir.
But let's say if it is base b, then this is base b, then it will be sigma I is equal to 0 to k di into b power I, and each of these digits, they will be between 0 to b minus 1. Like for example, if it is octal, b will be equal to 8, and the digits will be from 0 to 7, and this di, yeah, all these digits will be from 0 to 7. So like for example, if you take 24, which in octal, this is equal to, what is it equal to? It is equal to 2 times 8 power 1 plus 4 times 8 power 0. So this is equal to 16 plus 4, which is 20. This is in decimal. This is 20 in decimal. Are you with me here so far?
Yes, sir.
You're all with me here? Any questions you want to ask? We'll take it slow, so there is no hurry. I'm just trying to see how do I get
Sir,
to. Yeah.
I want to explain my approach a little bit. So in the case of
No, we will
800
go to
and
your approach. I think there is a I'm not sure. Let me tell you a clean way of doing it, and then we will
okay, sir.
revisit your approach. Okay.
Okay, sir. Sure, sir. Sure.
So, and then we will see, I mean, what's your approach, and if there is any problem in that approach, we will see. So, in order to, if you want to get, if you take this general representation, so if you take this general representation, if a number is, like the same number, you can represent in, either in different bases. Like for example, let's say there is some decimal number 843, and this is in base 10, and you can represent it. Let's say you want to represent 843 in some base b. Sigma I is equal to 0 to k di times b power I. Okay, you want to represent it in base b. And so in order to represent it in base b, we need to know what is d0, what is d1, what is d2, what is dk, etc. So essentially representing it in base b is nothing but finding out d0 to dk in base b. So if you, in order to figure out what is D0, the simplest thing to do to figure out what is D0 is, if you apply a modulo operation, mod B operation on 843, if you apply mod B, what happens is, you may have studied A plus B, yeah. So modulo some D is equal to, you can take mod inside, A mod D plus B mod D. You can take this modulo inside. So if we apply mod B to this whole what is there here, if we apply a mod B operation, then all the additive terms, they go to 0 except d0 term. D0 times b power 0 is 1. So except d power 0, all the terms will go to 0. So what remains is you get a d naught. So when you take 843 and when you want to try it to octal, if you apply mod 8, immediately you get the d naught term here. Immediately you get a d naught term here. Are you with me here?
Yes, sir.
So that's the first step. Immediately you get d naught. So once you get the d naught, you want to transform the number into a different form, so that you want to take d naught out from it. So this is the whole number. So you have, so let's say for the sake of simplicity, let's say this is d3 into b cube plus d2 into d square plus d1 into b plus d naught into b power 0. So you want to find out d3, d2, d1, d naught. So when you applied mod b, so all these terms got knocked off, and what you got is d naught. So you are able to extract d naught from it. Okay. So now what you should do is, from this number, whatever the number that is there, let's say this number is capital N. So from this number, what we should do is, when you subtract d naught from it, and when you divide it by b, what you get is, you get a, let's call this as n1. The number that you get is d3 times b square plus d2 times b plus d1. Now again you apply, so here you obtained this d naught by applying mod b operation. So again, in order to get d1, what do? You apply mod b. then you get D1. Great. So yeah, you got D naught, you got D1. So now what's the next step? You take N2 and this whole number is N1. From N1 you subtract D1 and you divide it by B. What you get is D3 times B plus D2, and you apply again mod B. What you get is D2. Great. So now what you do is you take N3, N3 is equal to N2 minus D2 divided by B, and what you have is D3, and you apply again mod B. What you get is D3. So now when we have N4, N4 is equal to N3 minus D3 divided by B, and this whole number turns out to be 0, at which case, you say the job is done. Apply mod B, whether you apply mod B or not doesn't matter. All you have to do is you take 0, you take D3, D2, D1 and put them together. You get the number n in mod base B. This is the systematic approach to go about translating a number in, in one base, like decimal base, to an octal base or whatever the base B is. The first question is this, do you understand this approach? First question.
Yes, sir, I do.
Yes, sir.
So once you understand this approach, for that problem, all you have to do is you just have to write no n1 is equal to n1 minus d naught divided by b, like that. You just write 4 and then you just you store them in 4 different variables and you print them in the right order. That's all. You store them in different variables and you print them in the right order. That's it. What is the right order? Because you cannot immediately print. Yeah, actually you can immediately print them because you are actually getting them from least significant digit to the most significant digit. Okay, so you can print it also immediately. It's not an issue. And you can write, now that you know loops, no, you can write it much more easily using loops too. Okay, so if you're all fine with this approach, if you have any questions here, I will take those questions first, and then I will see the particular approach which Ame has taken and see if how we can fix that. So you're all good. So shall we? If you're all good, then we'll proceed and take Ame's question, and I'll stop sharing, and I'll see how he did it and try to get some, see how to debug it. Okay, Chinmay has a question. Okay, Chinmay, go ahead.
Sir, I have a doubt for one of the problems. If Ame is going first, then I'll go after him.
Sorry,
Is Ame like I have a doubt in one of the questions. If Ame is going first, then I'll go after him.
I'm not able to hear for some. There's some noise in my office too. Can you speak a bit loud? I'm sorry.
Okay, is this better?
Yeah, so you just go ahead and see whatever I can make. So there is some trouble with AC. It is making some noise, but it's okay. I'll try to hear. If I, otherwise, we can type in the question also. So go ahead. Let me try to see. But if it is related to this problem, I will take it. But otherwise, I will hold it and then revisit your question.
Okay, it's for a different problem. So could I go after this problem's over?
Yeah. So let's wait for a few minutes. Let's finish this one and then we'll take up that question.
Okay.
Sir, can I share my screen?
Yeah, yeah. Please let me I'll share and yeah. Please go ahead. And,
Is it visible, sir?
Not yet. Yeah, now it is visible.
Okay, so sir, I did the same thing. So I'll just write it side by side. I'll open a new one just to show what I'm doing. What can you see, sir, on what is visible on my screen? If you
I'm
could
seeing your
describe.
program.
Okay, so what I did here was I first took the number and I took the floor by dividing it with the largest power of 8. So I took the opposite approach. So you started from the ones place, then tens, then that way. I took the opposite approach. So I divided by the largest power and I floored it. So for example, if I have uh, can you see what I'm typing right now, sir? I'm typing side by side. Um,
Okay, go ahead. Yeah, I can see. Yeah.
um,
Go to the code
what?
once, please. Just go to code once before I.
Yes, sir. Yes, sir.
So P is equal to you're taking 8 power 4. So the higher order term gets knocked out. You take 8 cube. The next term gets knocked out. A square. So great. And the problem is when you divide it by 8 power n 8 power 4, when you divide it and you floor it, let's say the digit is 8 plus, let's say it is 6.
So, sir, I'll show you what I mean.
So
So,
what is the
suppose
problem you are getting? It's not working.
no, sir, the number gets too big, like it's in lakhs. So there's some problem with it. So, sir, just for example, if you can see my screen,
Go
let's
to the
take three.
1 minute before
Yes, sir.
you wait. Let's see the code now.
Yes.
Let's see
Yes, sir.
what's
Sure.
happening. I'm not sure you are taking everything as integer and you are applying a floor. Then can you make n? Can you say so before n? Can you make something like put do one thing in the program on line number 6?
Yes, sir.
Let's say declare float m is equal to, yeah, that's all. Yeah, close it.
Okay.
Close it means yeah. Now come down to line 9.
Okay, sir.
Now m is equal to 1.0 into m into n. Yeah, so now wherever line 10 use m instead of f. Yeah,
Yes, sir.
similarly line 13. Line 11 leave
Uh,
it as it is. Line 13. Oh, okay. Line 12 you use m is equal to 1.0 into
okay.
p, like that.
Okay, sir. I think I understood what you're. So, sir, is this correct?
Yeah, it should be. And no, you should change it. So yeah, wherever p on line 13, that p by change it to m.
P by M or
Oh no, not p by m. Replace p with m.
okay.
Essentially, I want you to use a float there. So see if it, yeah, maybe try it now. Compile the program and see what happens.
No, sir, it's not working.
Can you show me? Can you share your screen or do something so that what is it showing?
Yes, sir. Yes, sir. Can you see the terminal now, sir? Sir?
Enter the number 1953 in octal. Your number is A, B, C, D. No, I think the problem is A, B, C, D, E. No, but A, B, C, D, they are now A, E. No, no, you are doing something wrong in printing. Oh, okay, you are, that's what, okay. Int floor A, B, C, D. You should print A, B, C, D, right?
Yes, sir. So A, B, C, D are supposed to be the digits, and
Put
I'm just
tab
simply
between them.
writing them.
Can you put tab between the percent D so that we will know what is A and what is
Between all of them?
yeah, dollar.
There's some error, sir.
Use minus LM. GCC, no, compile it using minus LM option. Minus LM. There should not be space between minus and LM.
Yes, sir.
Undefined floor is working till now, na?
Yes, sir. It was. I've even included a math.h, so
Yeah, yeah,
I don't
that's
know.
what it is.
చింపిస్తావా
So I don't see the, and you have been using it till this point, na?
Yes, sir.
Then suddenly why is it giving a problem?
So I think maybe it's because of the float value that we put in. I mean, it's flooring. So I'll try to explain, sir, what I'm doing.
No,
What
no, I
my logic
understand
is.
what you
So,
are doing. So my what see the when you are trying to extract the most significant digit, I'm not sure whether it is coming out right or
sir, what I'm doing here is I take the number, whatever it is. So, for example, in this case, if we take octal, the biggest power of 8, which will divide this, will be 64. So, I will divide this, and whatever it will be floor of that. And what I'll do is I'll put this modulo function as well. So, whatever, say, n number is it, then I'll do that 343 uh, modulo 64. So that way what happens is 60, what we get is 64 into some digit, which will be the first digit in the code, and this n will we will repeat the process with n again, but a lower power. So what I'll do is n equals
no, no,
floor
so I
of.
understand. Just let me share my screen once and see what you are
Yes,
trying
sir.
to do. And the problem which I am thinking could be an issue.
Yes, sir.
See, what you are trying to do here is you have the n there. So let's say this is n here, and let me continue on this screen. So the approach that you are taking is you are taking n and you are dividing it by b cube. So when you divide it by b cube, approximately something like this happens: d3 plus d2 by b plus d1 by b square plus uh, d naught by b cube. This is what happens. And you are taking a floor of this. And if all these things don't add up to, I'm just assuming that these things, they won't add up to, 1 or greater than 1. Uh, if they don't add up to anything greater than 1, then what happens is the value that you get is d3 point something. So when you take a floor of that, you get d3. So what at this point, what I am not sure when is whether all these things are, is there any case where when you add these things together, it will sum up to some value greater than 1 or not? I'm not sure.
Sir, if it sums up to be greater than 1, then the D3 itself will get incremented by 1, right? Because that
Yeah,
uh,
I think maybe you have to argue about it. Let's assume it's the case. And then in the next case, what you are doing is you are taking n percent b cube. When you take n percent, the next number that you are taking is n percent b cube. And the leftover number is is d2 b square plus d1 into b power 1 uh, plus
yes, sir. And I
naught
repeat
into
the whole
b
thing again.
b naught b power 0, and then again you are taking floor of n1 by b square,
Yes, sir.
and so that gives you d3 d2 hopefully. And then in the next case you go to n2 is equal to n1 by b. So this is your approach. So assuming your argument is all right, that no, these things, they don't add up to 1 and you don't get into trouble, then the problem is in the data types, and that's what I'm trying to tell you, that if you kind of map it to float, uh, yeah, so now you can share your code one more time to me. Share your screen. I'll stop share. This is the logic, and you can share your screen and you can tell me what is the issue there. We will try to see what's going on.
Yes, sir.
So now here, yeah, so M and see what happens is it should not be an issue. It should 2 point something. It gets, you don't even need to do a floor. Maybe you just remove the floor and see what happens. Did you try without using a floor?
Sir, if we use floor, then we'll get the 3 point or 4 point something something, and I'm directly listing this as a digit, right? So if I want to list A as a digit in the end number, then it can't be digit
No, but
at some.
it will be 3.14. If you don't have floor, then it will be 3, right? It gets truncated. The value gets truncated. Why do you want to use a floor there?
Yes, okay.
So
But
can you remove that? You can remove the declaration on line 6. Remove all statements involving M. Remove the floor and see what happens.
Sir, can I come in?
Yeah, sure. Who is this?
This is Tanmay, sir.
Yeah, tell me.
Sir, when I wrote a program that tried your approach, the modulo one, My PC antivirus is blocking it, saying it's a virus and the program isn't executing.
No, it cannot be the case. How is it possible? What is going on your PC, man? What is there for the virus to crib? I'm not sure, not at all sure. Maybe I'll see your program. That is completely weird.
Yes, sir. So, is this what you are saying, sir?
Yeah, so
But sir, it will not be valid, no? So because a is an integer, and if it gets some 3.14, then it will be invalid, no? So
no,
I'll
if it
have to
is
put
3.14, it becomes 3. It gets converted to 3.
okay, so
If
I'll
A is, that's how in C, if you assign a no real number, so the fractional part gets dropped and only the no the integral part will be taken.
okay, so I'll try and
Compile the code
execute
and
it.
see what happens to it.
Yes, sir. Yes, sir. No, sir, it's still not.
No, no. So I think there is something. Can you print? See, you are right now. You are not seeing what is A, what is B, what is C, what is D. You are just printing them together. So you have to print them separately. Put a tab between the percent D. So you need to learn these debugging approaches because what information you are getting out of that thing, you are not getting any information except that it is not the right. So now maybe if you print like this, you'll get some idea on what is happening over.
Yes, sir. So A is coming out to be a very large number, and the
So
rest
why
are.
is A turning out to be, so 1953 divided by 8 power 4, what is it? Do you know how
Sir,
to do GDB?
I'm not very good at it, sir. I'm
So let's
learning
do
it.
it now. So do GCC minus G, GCC minus G, yeah,
Yes, sir.
GDB A dot out, break B space main, yeah, run,
Um, Next, right,
RUN
sir?
run, next, yeah, next, yeah, do a next, yeah. So now enter the number, check print n, check if n is getting printed right. Okay,
Yes,
so
sir.
now print uh,
Print A,
so
right?
yeah, so print a, now do next. Actually you have to, you still didn't execute that statement. Print, yeah, next, yeah, print a, yeah. So what is n? 1953 divided by 8. Oh, this is, I understood the problem. There is no not 8. That 8 caret 4, it is not 8 power 4, Ame. So it is right. There is, you have to do 8 star, 8 star, 8 star, 8.
But sir, I included math.h,
No,
so
no, no.
shouldn't
Even
it?
if you include math.h, you have to use power function. Pow, 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 you have to use.
Oh, okay, sir. I see it, sir. So if I'll just write this again and write 8 to the 8 to the 8 multiplied with,
Yeah, you
and
just have to write.
that should.
There are two ways of doing it. Since math.h is there, you can use the library call. Use POW 8, 4 as the parameters. That is one way. Yeah, 4.
Okay.
But there, like you cannot have 8, you cannot use POW in the remainder. So because you can only take remainder with an integer, So my take is just use 8 times 8 times 8.
Okay,
Multiply
sir.
it by 4 times. That's the easiest. For the time being, just in order to see if your logic is going right.
Yes, sir, because I tried it on paper and it worked. So
Yeah. No. So you have to use one more 8 in the top.
yes, sir.
Last star replace it by 8. Yeah. So now it should work.
So I
You
think
can
so. This
comment
should.
out 22. Line number 22, you don't need it. Or you can do it for the sake of checking, you can have it. No? It's okay. Keep
But
it
sir,
like that.
it has carrots. It has
Yeah,
carrots. So I
remove them
think
with
it's
multiply, use 8 times 8 times 8 like that.
okay, sir. Yes. So I think this should work.
Yeah, control D. Go to come out of the program, control D. Yeah, Y. No. GCC. Yeah. Just don't do GDB, just run the program. Yeah.
Yes, sir. It's working now. I just have to
It's,
remove that T part now.
okay, yeah. So that's all,
Yes,
no?
sir. Yes, sir. Silly mistakes, sir. I
Yeah, I also didn't
okay.
notice it. No, it's all. So, anyways,
Yes, sir. Thank you, sir. Thank you. I'll stop
good.
sharing.
So I will take up questions from someone else so that others will also get an opportunity.
Thank you, sir.
No problem. Uh, so there is this question on how random numbers work. So, so let me take that question. So tell me what you understand about random numbers who are asking that question, and from there I will.
Sir,
So
I basically don't know how random numbers are like. I don't understand the code in C. Like, I have worked with Python before, and Python it was really simple. But C, sir, I did not understand the code. I did not understand what part is doing what thing. So, if you could explain that, please.
okay. See, that is the thing. See, that's the reason why learning sometimes Python is dangerous. Some magic happens, and anyway. So let's see. There are two things. Let's take our own random number generator first. LCG1. Let me use LCG2. So are you able to see this code? This is what is called as a linear congruential generator. Line 5 to... So here what we are doing is so in random number generators, um, the general form of random number generator, what we do is we start with x naught. X naught is a seed. Just give me a minute. Okay, it's okay. I'll manage with this. This is also bad. Anyway, so we start with uh, some something called as some seed. This is what is called as a seed. And in order to kind of make it look random, you do some kind of computations, and you generate something, and then again so seed is something to start with. Okay, seed is when you will see what seed means, but anyway, so let's say we start with some number and let's call it as seed. Whatever it is, let's call it as a seed. Okay, we start with some base number, let's call it as seed. And yeah, and then what we do is, in order to generate the next number, we say we kind of apply a mathematical function. Ax1 is equal to ax1 plus c. And then see, ax0 plus c. So from x0, x0 is getting fed here. From x0, we are generating x1. And we say x2 is equal to ax1 plus c, so on and so forth. So what happens is, if you start with some supposedly random seed, which is based on, like, for example, what is the current time, or based on something, some event, you kind of get a seed, which we cannot associate any semantics with. Let's say, we call it as seed. That's what we are trying to do on line number 16. So time of 0, it kind of but that is not exactly random, but no, to you it is a random, because when I run this program, will you be able to say anything about it? Like, for example, if I kind of compile this program, this is LCG2.c. If I compile this, do you say anything? Can you say anything about this? Can you kind of argue anything about the numbers that are getting generated? So it looks random, right? So can you say anything about those numbers? Why is it defined? I didn't get your question, Yash.
Sir, am I audible now?
Yeah, you're audible.
So you wrote hash define A as 110351524.
Yeah.
So where did that number come from?
Okay. Good question. So we will come to that. But if you just have this, again you have x3. We have x3 is equal to ax2 plus c. But if you kind of just keep doing like this, what happens is this is a multiplication operation. The value will not be bounded. So in order to contain this number, we apply a modulo operation. We kind of take mod m. That is, we want to constrain this number. We want to constrain the number within that same range. So in order to constrain these numbers within some range, we apply the modulo operator. So in general, xn is equal to ax n minus 1 plus c mod m. This is one kind of, there are many kinds of random number generator functions. So this one, but this is what is called as a linear congruential generator. This is one particular function. And so when you kind of call this rand function again and again and again, uh, like for example, whenever you want a random number, you can just do this operation, starting with some seed. That seed is set when you start your execution of your program. So it may or may not be random. If you look at it, it looks like random. But depending upon the case, like for example, if you take A is equal to 2 and C is equal to 0, then all the numbers that generated could be even numbers. So when you look at the random numbers, you can look at those numbers and say, you know what, all the numbers that you are generating, they are not truly random, because all the time you are generating even numbers. And if you try to simulate a die, uh, so this when you try to simulate a die using such a random number generator, you may all the time get like only 2, 4, and 6 as the dice. So it could be a problem. So this is nothing but 2 power 31. What this means is 2 power 31. Take 1 and shift it to the left by 31 bits, means its value is equal to 2 power 31. You're taking modulo 2 power 31. So, wait. So I think you have questions. So in order to this A and C, they are kind of experimentally chosen so that they don't. We kind of the numbers that are, if we kind of arbitrarily take these numbers A and C, no, they may not quite, the numbers that we get, they may not be quite random. So through experimentation, people choose these constants A and C. There is some theory and there is through some experimentation. They say, like if A is, for these values of A and C, the number sequence that you have generated, it looks random or more random rather. And so in a program, when you are, if you want to generate a sequence of random numbers, then you can just keep calling this line number 18 again and again and again. Like for example, I can say, so this is the seeding process is happening. I can say R1, first random number is this. Okay, so this is R1 is this. So R2 is this, R3 is this. Like that you can do. Like now when I compile. So now we have generated 3 random numbers, one after another. The questions that I have given in lab 5 part 3 are essentially trying to figure out whether these numbers are really random numbers or trying to get some kind of intuition behind them. So the idea is it should not be possible to print the original value of, by looking at the sequence, we should not be able to figure out what will be, by looking at a particular number in the sequence, we should not be able to say theoretically speaking, what we kind of see is if I give you this number, you should not be able to guess the number before and you should not be able to guess the number after. So Yesh, what I would suggest is you do read the man page of time and try to understand what happens if you use time 1 there. So there is a reason why we use 0 there. It's not a big reason, but what we want is some random value to be initialized to we want to get, and time is one way of doing it. Other way of looking at it is, no, if you have a camera, you look outside, no, you take a picture of the what is there present outside, and from that you compute some value, and it could be a random number also. So there are different ways of seeding. Seeding itself is a painful process. So we have to seed things in the appropriate fashion, but the idea is from a given a random number, if from R2, let's say if you are generating OTP, so from the current OTP, you should not be able to generate the next OTP and things like that, or the previous OTP, because they all use some kind of random number generators. And so there is this question, what happens if you uncomment comment line 18? So what happens if you comment line 18? So you are not computing, no, x1 is equal to ax naught plus c, you are not computing. So whatever x naught is, it gets printed. So no surprise. Are you with me here? Are you all with me on this idea? Yeah, that is true. No? So if you do, it's, I think it's, let me do, it's very simple. Let's try to do a GDB. Are you able to see my screen? Okay. So GCC LCG2 minus G LCG2 GDB A dot out break main run. So UI. So what is the current value of X? We are at line 16. It's not yet executed. If I print X, so it looks to be 0. I don't know why it is initialized to 0. It may not be initialized to 0. And if I say next, so now if I print X, so this is the value of X. So now this value of X is supplied. So this value of X is supplied here. This value of X is supplied here. And so we compute next. And now if I print X, so this is the new value of X. A, C and M are fixed. That's true. A, C and M are fixed. They are not going to change. Rachit, do you understand what is happening here? So this value of X is supplied here, and we are computing this and we are storing the resulting value back in X. And then the same thing is happening. This value of X is being supplied here, and you compute A star X whole percent M, and you get the new value of X. And then this value of X is again being supplied here, and you say X is equal to whatever this, and so that is how this whole computation is happening. And what you do is, so let's say if you want to generate a sequence of, random numbers in the range 0 to 5, then you take this and you compute modulo 6. When you take modulo 6, the values will fall between 0 to 5. So one question in lab 5 is part 3 is you do that. So you do it 1,000 times, million times, and see what is the frequency with 0, 1, 2, 3, 4, and 5 are occurring, and see if it is a uniform distribution or if it is close to uniform distribution or not. Are you with me on this one? Does it make sense? Shivangi, do you understand now what's going on? Okay, so shall I move on? If you're all good on random numbers, shall I move on? So Chinmay has a question, I will take that question. Okay, Chinmay, go ahead and ask. What's your question?
No, that's what I was going to say. If we're finished, could I go next,
I
or
am
do
not,
we have to wait
my
for someone?
speaker is not good, so either you type in or some magic has to happen and I should be able to hear your voice more clearly. Can you talk once, one more time loudly, and if it doesn't work, then you can.
Sir, there's this one question in lab 4 part 1 for like expansion of e to a some number limit.
Lab 4 part 1.
Yeah,
What is that question?
it's question, where
You
is
can
it?
share the screen with me. It's easy to.
Yeah, just one moment. Um, yeah, it's here. So, one second. It's saying I cannot start screen share. So,
You cannot start. Okay, I'm stopping my share. Okay, yeah, please go ahead. No.
okay, fine. Yeah. Is it visible?
Yeah, it is visible.
So it's for question 11.
Hmm.
So what I've done in VS Code is this. Now, when I try executing the function, I showed this to the TA also. So for small values, it's giving like if I put a limit as 1 or 2, it's giving an exact integer. If I'm
Small
giving
values.
like 1 or 2 or 3, it's giving an exact integer. If I'm giving a value, if I'm giving like a value like 10 or 20, it's getting very close to the value of e. And if I'm getting
I am
giving a
not
value like,
getting you, Shinmay. So
yeah, I'll just show you. So yeah. So if I enter a number limit of 1, I'm getting like an exact integer if I'm
what
entering a
is the
number
limit?
limit.
Can you share the problems at one more time? I want to read the problem before you.
Hmm.
Problem number
11.
can be expressed as an infinite series. Write a program E by computing where n is the integer expressed by the user. Okay, so it should be 2, no? It should come to 2, right?
Yeah, that's what's happening for now. But when I give like um if I give like a large value like 1000, or 100, it should approximate to the exact value of E.
It
But instead
cannot,
it's
because
giving
it will be
this,
difficult. Huh?
giving infinity.
Because 1000
Why is that?
factorial, your the denominator is factorial, right?
Yeah.
Yeah, 1000 factorial it cannot compute. So how are you computing factorial? Can you show me the code? Yeah, so large values. So 10 factorial, even 10 factorial is hard to compute. Hard to compute means the value doesn't fit into, yeah, it becomes so large it cannot fit in. It's 1000 factorial is too big. It cannot fit into your into the size of the float. So it doesn't work. Even 100 also becomes very difficult.
Yeah. And there's one of the quest examples in lab 4 part 2, like in the arrays chapter. It's here. Yeah, so this is of the program that checks for numbers for repeated digits. So in the programming projects, we have to modify this program. So we've defined a digit seen like an array of 10 digits as a bool value. Why? Like I do not get this definition. How is it working?
Sorry?
I'm not understanding the first line definition inside void.
No, it's very simple. All it says is declare a Boolean array. Name of the Boolean array is digit underscore scene. It has 10 entries starting index. You can index them as a digit 0, digit 1, so on and so forth. And each of them are initialized to false. That is the semantics of it.
Okay. So yeah, that's all I
And the
wanted to
idea
know.
is very simple. You assume that initially that you are not seeing any digit, and then as you see digits, you change the corresponding flags to true. That's all.
Okay, because I didn't understand how that was defined.
Sorry?
I didn't understand how that was defined.
Now, what you didn't understand. So that statement is, it's like English language, just like C language semantics says. If you read the text before that, if you just use one entry, all the elements in that array they will be initialized to false.
Okay. So yeah, that's those are the only two doubts I had. Thank you, sir.
Okay, so that is the idea. It's like the language. That's what the language semantics says. Any other questions?
Hello, sir. Can you hear me?
Yeah.
Yeah. So actually, what Chinmay showed, I had a similar doubt in that, like, when do you use two equal to signs and when do you use a single equal to sign? Because I thought in that one, you should be using two equal to signs because if
Two
it's
equal to sensor.
right, it's a Boolean value, right?
No, 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 no. You got it completely wrong. You got it completely wrong. So you are, when you want to compare whether two values are equal to each other, then you use two equal to signs. Not at all. I think you are completely confused there. Let me share the. Let me write a small program for you, and I will share my screen. Okay. So let me come out of this. So, like for example, you can just say printf array and So you want to check, let's say you want to check if both of them are equal. So you use whether the contents of the variables a and b are equal by using the equal to operator.
Okay, so you only use it to check whether they're equal, right? The values stored
Yeah,
in them are equal. That's the only time you use two equal to signs.
yeah, that's true. Input values are equal. So this is yeah, and
Okay, okay.
you can see GCC eq.c dot order a dot out at 23, 33. You don't get anything, but if you say 23, 23, you say the input values are equal. So in order to check whether two things are equal, you use equal to operator.
Okay, so
As against, I can use a bool variable, bool some flag. I can initialize it to some true or false or whatever it is. So that is different. But if I want to use bool anyway, I have to include std bool.h.
okay.
Okay, so the boolean variable is completely the true is this equal to is an assignment operation. This double equal to is a comparison operation.
Okay, so understood. So that's the only use case, like to compare two inputs, right? That's the only use case for double equal to.
Yeah, double equal to is when we want to compare whether two entities are equal to each other or not.
All right, so that was my doubt. So actually, I had one more general doubt. Actually, uh, can I
Okay,
ask? Yeah,
go
yeah.
ahead.
Yeah, the thing is that, so I'm able to follow whatever is happening in class. I'm able to follow that, but I just feel that sometimes when I'm doing the lab problems, I'm a beginner in this is the first time I'm coding, right? So I just feel that sometimes when I'm doing the lab problems, I don't know where to start in the lab problems. And I felt that in lab 4 part 2 some of the questions. So is it possible for you to do like some examples in terms of how to, the way of how you should start thinking when any problem is given in
Uh, See, what
like
I would say is in the class we use a combination of language and computational thinking. But when you have the best thing is to the TAs, no, all the lab problems. When you have a problem, you attend the TA hours and ask, I have this problem. How do I get started? And they will give you very good pointers. We will do more examples. So because going forward, because till now we are trying to understand the language features, etc. Uh, so going forward, we will use see more examples. But meanwhile, the best thing is to talk with the TAs. You start with a problem and see how you want to go about thinking that problem. So that part you may want to check with the TAs. But definitely in the class, we will see more examples going forward.
all right, thank you, so thanks for clearing that up. Thank you.
Okay, what else? So what is the problem, Tanmay? Can you show the code you have and tell me what's going on?
Yes, sir. Can I share
Yeah,
my
sure, sure.
screen?
You can share your screen, no problem. Yeah, so false means zero, Rachit. Yeah,
Sir, first you'll have to unshare your screen.
you have to unshare my screen. Okay.
So this is the program which I wrote.
Okay.
And when I'm compiling it, it is getting compiled. When I try to run it, the .exe file gets deleted on its own.
Let's see. Let's see. You are in Windows. Okay. Let's see what happens. What is happening?
So it is trying to run the file, but then it gets blocked by the antivirus and the file gets deleted.
Oh, is it?
Yes, sir. See,
Oh man.
so is something wrong with the program or with the antivirus?
I'm clueless, Tanman. Say, I'm looking at this problem, this kind of problem for the first time. Why it should be an issue? Did you get in this kind of problem for any other things?
No, sir, not yet. This is the first time.
Why is the antivirus thinking that? Can you compile it to some store it in some executable gcc octal.c minus o
Yes,
octal?
sir. I'll try.
I think the same thing seems to happen.
Right now I can see the file, then it get deleted.
What's the error the antivirus showing?
It says that there was a virus in the file octal.exe and it deletes it.
Compile it again once.
Yeah.
Do a file space, don't run it, file. I don't know whether it works or not. If the command is there, file space octal. No, yeah, so okay, file command is not there. Can you do a, is gdb there on your machine?
No, sir, GDB is not yet installed.
Do one thing, comment out the codes 10 to 14. Now compile the code and run what happens. Yeah, run it. Okay, no problems. It is printing. Now can you uncomment line number 10? And run it. Okay, so now we'll uncomment one more line and see what happens. Okay, that's fine. So now uncomment line 12. Okay, uncomment line 13.
There's a problem in line 14, line 13.
Okay, so just comment line 13 and uncomment line 14. Yeah, so maybe some kind of signature in that code which the virus is not happy about. You can try to rewrite the code. Anyway, that code is very badly written. So sorry, in the sense it's a bit confusing. So why don't you make it more like, for example, you can do one thing. No? You can d1 is equal to n percentage, d2 is equal to n minus d1 by 8. Uh, Instead, use the notation uh, n2 is equal to n2 is equal to n minus d1 by 8, something like that. So n2 is equal to n minus d1 by 8. And wherever that n minus d1 by 8 is there, you replace it with n2. So similarly, you say n3 is equal to n minus d2 by 8. It should be n2 minus d. n3 is equal to n2 minus d2 by 8. Yeah. And d3 is equal to n3%. D3 is equal to n3%. Yeah. So now again n4 is equal to n3 minus d3 by 8. You should cut it and then put it after d3.
Should I try now, sir?
Yeah, compile now. You're still getting the same problem.
Yes, sir. Maybe I'll write the whole program once again and try.
But surprising how it can. What is the problem? Why it is it very weird, very
See, sir.
weird, generic. Is there some virus? Is it? Can you search for that virus? What is that thing? Say virus generic RxA.
This is the first time I'm encountering this virus.
Yeah, I see something wrong. So you should check that. I think there is nothing wrong in the program logic. Some why is that virus or whatever that is coming. Please check once and see what's going on.
Yes, sir.
Okay. Anything else you want to ask Tanmay?
No, sir. Thank you, sir.
Shivangi, what's up with you? You want to ask any question or we can break for today? Okay then, I think we will break for today.